everyone, welcome back to the design and analysis of algorithm series. So today we are going to solve asymptotic notations of omega. So we shall take an example as 10n squared plus 4n plus 2n belongs to omega n squared. Okay, so this is an example for omega which explains the time complexity for the lower bound time complexity example. So f of n greater than or equal to c star g of n. This is the condition belongs to the lower bound of the omega. So what we are having? N square. So n square greater than or equal to n square. So this condition satisfies. So this is an valid omega notation. So this is a valid omega notation which help us to find the lower bound time complexity. Okay, na? Suppose if consider that it is having the n power 4. So n squared greater than or equal to n to the power 4. Is it true or? No, this is not true. This is false. So this is not a valid asymptotic notations of omega. So this particular condition f of n greater than or equal to c star g of n should be satisfied. Then if it is a valid only, we will be able to solve the problem. So here what is given already? N square. So we shall solve it for g of n square. We shall take the f of n. So what is the f of n given? So 10 n squared plus 4n plus 2 greater than or equal to. So what is the value of c? We need to take 10. Why? Because the condition is greater than, f of n is greater than, at some n point we shall consider at some n point this f of n, this is c star g of n. So this is a g star at some n value, this f of n is greater than the c star g of n. We need to find out the n, at what point of n this f of n is greater than the c star g of n. So definitely it should be less than, that c value what we are taking should be less than or equal to 10. So 10 n squared is the given f of n and it should be less than. Okay, na? So we shall take the c some constant value as 10. G of n can be n squared. Why? Because now it is given. Suppose if the value is not given, na, then you can take n squared also. Why? Because now in the left hand side given f of n is the n square. So greater than or equal to 10 n squared. So this is the condition for omega. So now we need to find at what point this f of n is greater than the c star g of n. So we shall start applying it for the n value. If it is 1, 10 into 1 squared plus 4n plus 2 greater than or equal to 10 into 1 squared. So what is the value we will be getting now for this equation? 10 into 1. So 16. We need to calculate this value. We need to calculate the value for 10 into 1 squared plus 4 into 1 plus 2. So 16 greater than or equal to 10. Yes, that is true. So when this n is equal to 1, f of n greater than or equal to c star g of n. The given condition is true at this point. So if you apply for n is equal to 2 or 3 or any value, then this particular f of n is greater than or equal to c star g of n. That is nothing but this is the omega n squared. Omega n squared. That is the given condition which is satisfy the omega asymptotic notation here. So what is the remaining one left out? The remaining one left out is the tight bound. Tight bound is nothing but it lies in between the C1 and C2. So f of n lies in between the C1 and C2. So what is the given in f of n? We shall take the same example. 10n squared plus 4n plus 2. We shall take this asymptotic notations of big O and omega. So what is the conditions lying between the If it is C star G of n is less than, we shall take 10 n square. Okay, now that is lower bound. So big O, upper bound means what is the C value? 11. Definitely it should be greater than upper bound. Upper bound means maximum time complexity, which is belongs to big O. So this part is belong to omega. So that is the thing which lies between the upper bound and lower bound is the average case time complexity, and we need to find it out the value for applying n is equal to 1 or 2 or where it satisfies the condition for both the thing omega and big O. So already we found that this big O and individually we found out the omega. So this tight bound lies in between the two cases. Okay, thank you. We shall see the next example in the next video. Thank you.